Hey guys, tonight we're headed deep into the humid heart of Central Africa, Gabon, to be exact, where something deeply odd happened in 1972. Not odd, like, my socks are mismatched, but odd, like, did someone just find a nuclear reactor? From 2 billion years ago. Yeah, that kind of odd. Picture this fluorescent lights buzz softly over a lab bench in France. A scientist in a crisp lab coat holds a Geiger counter over a fresh sample of uranium ore. And then, he frowns. Again. Beep. Beep. Still low. The readings aren't adding up. This uranium isn't as radioactive as it should be. You probably won't survive a nuclear mystery like this if it were to unravel in your kitchen, but don't worry. We're just eavesdropping from the safety of your pillow. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, comment with your location and what time you're listening. I'm always curious who's drifting off from which corner of the world. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The uranium had come from a mine in Gabon. Nothing exotic, just another pile of radioactive rocks pulled from the earth. France had imported it from a site called Oklo, a sleepy place that had been delivering ore like this for years. But this batch, it was different. See, naturally occurring uranium contains about 0.72% uranium-235, the isotope that's actually fissionable. It's what powers your nukes, your reactors, and all your favorite doomsday documentaries. But this uranium only had 0.715%. That may seem small, but in nuclear physics, that's like someone shaving a tiny sliver off your parachute cord mid-fall. So naturally, they ran the tests again. Same results. The French government got involved. Physicists perked up like cats hearing the sound of a can opener. And so the French Atomic Energy Commission dispatched a team to Gabon to investigate. Because clearly the jungle was up to something. Let's stop for a moment and appreciate how backwards this sounds. A group of elite European physicists was sent to Africa not to build a nuclear reactor, but to find out why there already seemed to be one. They went looking for answers in the rocks, expecting a glitch in data, maybe a sampling error. What they found instead was humbling. Hidden inside the ancient geological formation at Oklo were signs of a sustained nuclear chain reaction, one that had taken place millions of years before humans had even figured out how to shape stone tools. Now pause. Sit with that. Imagine going into a cave and realizing someone had built a car 2 billion years ago. That's what this felt like. The reaction zones there were several showed clear signs of fission products, isotopes, like neodymium-143 and ruthenium-99, the kind you'd expect to find inside the core of a modern nuclear reactor. The rocks bore scars of neutron bombardment, and the ratios of uranium isotopes were all wrong in exactly the way they'd be if a nuclear reaction had quietly simmered underground for hundreds of thousands of years. It wasn't just weird, it was textbook. If someone had handed this data to a nuclear engineer without telling them where it came from, they would have assumed it was a report from a functioning reactor circa 1980. Except, this one had no cooling towers, no control rooms, no humans. Historians still argue whether the discovery at Oklo should be framed as an example of nature's staggering coincidence or as a relic of something older, something that doesn't fit into the neatly stapled pages of modern textbooks. For now, the official story says the conditions were perfect, a rich uranium deposit infiltrated by groundwater sitting in just the right geological cradle. Somehow the Earth itself had created a nuclear reactor. But you feel that pinch of doubt, don't you? A little voice in the back of your mind, just loud enough to whisper between your ears, asks, what if this wasn't nature? And that's where your descent begins, not into sleep quite yet, but into a tunnel that curves slowly downward into the past. The kind of past that hums with a heat long cooled, a brilliance long buried. You lie there and wonder if there was once a civilization capable of building nuclear reactors long before history admits it was possible. What else did they leave behind? The scientists in Gabon didn't find temples or statues. They found data. But sometimes numbers are louder than monuments, and this batch of uranium? It was practically screaming. Still, the earth stayed silent. As always, the jungle vines hung motionless around the cratered mine. And the mine, oh, it didn't blink, didn't flinch. It just kept holding its secret a little longer. But not from you, not tonight. The jungle doesn't rush, it waits. Patient, damp, and humming with insect life. You stand at the edge of the Oklo site in Gabon, surrounded by an orchestra of crickets, frogs, and distant bird calls that sound like somebody's trying to whistle underwater. The air is thick enough to chew, and somewhere under your feet, just a few meters below the earth, once lit itself on fire. Not in a dramatic Hollywood volcano kind of way. No, this was quieter. Precise. A nuclear chain reaction simmering underground, self-regulated like an ancient heartbeat. And you're standing on its scar. Imagine for a second that you're not just a sleepy podcast listener tucked in with a fan blowing at your ankles. Imagine you're a French geochemist in 1972, dressed in safari khakis and regretting your life choices as you swat at your 50th mosquito of the hour. You're here to solve a mystery why this uranium is missing its punch. But what you find is something deeper. The Oklo mine itself doesn't look like much. Just a rocky pit framed by trees and mud. No glowing green ooze. No temple to a forgotten god of radiation. If this were a movie, you'd already be rolling your eyes. But reality's always quieter and creepier. Samples are pulled from what geologists call reaction zones. At first they only find one, then another, and another. In total, 17 separate zones, all showing signs that uranium-235 had once undergone sustained fission. Let's pause there. That's 17 places where the Earth decided to run a nuclear experiment while the rest of the planet was still figuring out photosynthesis. The theory goes like this. 2 billion years ago, the concentration of uranium-235 in natural ore was about 3%. That's actually enough to sustain a chain reaction, roughly what modern reactors use, with enriched uranium. Now add groundwater. Not just any water, but slow-dripping ancient aquifers that seep through rock acting as a neutron moderator. That's a fancy term for water's ability to slow down neutrons, increasing the chances of more fission events. It's exactly what reactors need. So you've got your fuel, you've got your moderator, the only thing missing, a spark. And over geological timescales, sparks are inevitable. The reaction starts, heat rises, the water boils off, reaction slows, cool down begins, water returns, and the cycle repeats. Over and over, for up to 1 million years. That's not just a fluke, that's a pattern. Historians still argue whether this delicate balance really could have occurred naturally, not just once, but in 17 different pockets. Some call it the Earth's most perfect accident. Others call it something else. You crouch down in the dust and run your fingers along a chunk of ore. It's heavier than it looks. Warm from the sun, not from any radiation, it's long cooled. But the whisper remains. What gets your attention isn't just the reaction itself, it's how clean it was. Modern nuclear reactors require constant supervision to avoid meltdowns. But this one, the Oklo reactor, it didn't melt, it didn't explode, it stopped itself when things got too hot. Some scientists joke that it was smarter than Chernobyl. You chuckle softly. It's a weird thing to laugh about in a jungle. But it's true. The natural reactor operated off and on like a heartbeat, pulsing with nuclear fire and pausing to cool. The idea that this happened without conscious control is hard to swallow, even for professionals. And yet no control rods, no electronics, no operators in lab coats, just Earth doing Earth things, apparently. But there's a strange stillness around the site, as if the jungle itself is holding its breath. You notice how the crickets have gone quiet. That thick background hum. It's more than bugs. It's waiting. You press your ear closer to the rock, not that you expect to hear anything. But sometimes silence is a kind of sound, and maybe the Earth does whisper, not in words but in half-lives and isotope ratios, in decay chains and neutron capture patterns. You just have to know how to listen. Back in the lab, data pours in. Every scientist expects to find chaos. Instead, they find elegance, predictable isotope shifts, clean-cut reaction zones, little to no leakage, fission products right where they should be. It's almost too perfect. And of course, the jokes begin. One physicist dubs it Gaia's little reactor. Another calls it the Stone Age nuclear plant. But behind the humor is an itch they can't scratch, because nature doesn't usually color inside the lines like this. You lean back against a warm rock and close your eyes. The air is thick with memory, if you let it be. Beneath you, the earth holds its secrets in layers of stone and silence. And if you listen long enough, if you slow your breathing to match the pulse of a world older than memory, you can almost hear it, not in words, but in hums, in the slow murmur of isotopes that have waited 2 billion years to tell someone what they did and how it felt. You're still sitting there, legs folded on a rock, warmed by the African sun, with a mosquito doing lazy orbits around your ear. The jungle, thick and vibrating with invisible heat, seems unchanged by the knowledge that you now carry. But you're not the same. Because now you know beneath your body lies something that once burned with atomic fire and nobody built it. Or at least that's what you're still being told. But let's say you tilt your head. Just slightly. Listen to the buzz between the official reports. You might start to hear the question that refuses to go away. What if it wasn't natural? Let's rewind. Oklo isn't just weird because it ran like a reactor. It's weird because it ran like a well-designed reactor. The reaction zones aren't random. They're layered, patterned, cleanly bordered. The geometry of the uranium deposits mimics something you'd draw on a whiteboard if you were designing a reactor from scratch, with moderation zones, waste distribution, and a structure that appears to have intentionally prevented meltdown. You ever tried to arrange a drawer full of mismatched socks? That's nature's usual organizational style. Chaos. But this was socks sorted by color length and emotional backstory. Historians still argue whether these geometries could be entirely geological or whether they're echoes of someone older. Someone who understood nuclear science before mammals even happened. There's no copper wiring, no concrete shells, no signage in long-lost scripts. But what if that's not because no one was here, but because someone wanted none of it left behind? Now take a breath, because we're about to step off the edge a little further. Some researchers, not the ones you see at TED Talks, mind you, but the fringe dwellers with dark circles and stacks of FOIA requests, believe Oklo is not an accident at all. They whisper about lost civilizations, and not the Atlantis with seashell crowns kind. No, we're talking about people who understood atomic energy, who may have once walked the earth long before Homo sapiens had invented trousers, or brains, really. There's a peculiar logic to this idea. If we had an advanced civilization 2 billion years ago, how would we even know the fossil record erosion and plate tectonics would have buried everything? Tech decays. Buildings crumble. Only nuclear evidence lingers. And what better evidence than a reactor that still shows trace signatures of controlled energy output millions of years later? Let's go deeper. In 1985, scientists at the French Atomic Energy Commission noticed something odd about the neodymium isotopes in the Oklo samples. The ratios matched fission product profiles exactly like they'd been made in a lab. In fact, if you put those isotopes next to ones from a modern reactor core, you'd need a lab coat and a magnifying glass to tell the difference. But here's the kicker. No natural process, no lightning strike or rogue cosmic burst can replicate that profile. Not cleanly, not predictably. You stretch your legs out. The jungle has grown quieter again. Maybe it's the heat. Maybe it's something else. You wonder what if this place isn't just hiding something, but guarding it. It gets stranger. There are patterns in the samarium isotopes, too. That's another fission byproduct one with a half-life too weirdly well-behaved. Some samples at Oklo showed signs of neutron capture regulation, as if the reactor knew when to stop and when to start. No modern facility can do that without assistance from control rods, feedback loops, and about 100 engineers monitoring it from a screen-filled bunker. But the Earth apparently did it with rocks and puddles. Sure. The skeptics understandably have questions. Even the more conservative nuclear physicists scratch their heads and mutter things like, well, maybe we don't yet fully understand uranium migration in Precambrian geological strata. Translation. We're just going to mumble for a bit until someone changes the subject. But you're not changing the subject. You're leaning into it. Because what if this wasn't just a fluke? What if this was the remnant of a society that knew how to use the atom, but not in bombs, not in fear, but in balance, in quiet energy left to hum beneath the surface long after its creators had vanished? Maybe they didn't go out in flames. Maybe they walked away, leaving their technology to die slowly, safely underground. And maybe we were never supposed to find it. Still someone noticed. The uranium discrepancy, the isotope fingerprints, the whisper in the stone. And now, you shift on the rock. Something firm pokes your thigh. A stick, probably, but you check anyway, just in case it's something older. Something that didn't forget how to hum. So here you are, surrounded by trees that haven't read a single physics textbook, listening to the Earth retell a story that's been buried longer than any civilization on record. You lean back and wonder not for the first time how on earth this could have happened without a single blueprint, without a single human hand lighting the fuse. Because, let's be honest, nuclear fission is not something nature usually dabbles in lightly. Yet the official story goes like this. 2 billion years ago, the universe decided to roll some very specific dice. And somehow it landed a perfect chain reaction in a rock formation in Central Africa. Naturally, of course. Let's break it down. To achieve fission, you need enriched uranium, a moderator, to slow the neutrons and geometry tight enough to sustain the chain reaction. You also need a way to regulate the reaction so it doesn't burn out too fast or blow itself apart. Not too hot, not too cool. Now, your high school science teacher probably didn't cover self-regulating prehistoric atomic furnaces, so let's picture it. Uranium deposits in ancient bedrock rainwater, seeping through porous stone groundwater, pooling just so. Neutrons begin to split uranium atoms. Heat builds. Water boils off. Reaction stops. Cool down. Water returns. Repeat. It's like the Earth built its own coffee pot. Only instead of espresso, it was making nuclear magic. Geologists who believe in this natural reactor theory point out that back then, uranium-235 made up around 3% of uranium, or enough for fission. Today, it's less than 1%, which is why we have to enrich uranium artificially. But back in the Paleoproterozoic era, the planet was apparently stocked for radioactive success. Convenient. Historians still argue whether this was luck or something else, because here's the kicker: for all the supposed randomness, the reaction lasted for up to 1 million years. Not seconds, not days, not even centuries. 1 million. That's a long time for a coincidence to keep its act together. Think about your microwave. It needs 17 microchips just to stop the popcorn from combusting. Yet somehow this ancient underground oven ran smoothly, quietly, and never melted itself into oblivion. And there's something else. You shift your weight and peer at one of the Oklo ore samples. It's been studied by labs around the world, and the results always raise eyebrows. The products of fission neodymium, samarium, molybdenum are all in the exact ratios expected from controlled nuclear reactions. It's so on the nose that if it weren't deep in the earth, you'd think someone cooked it up in a French lab with a deadline. Even more strange, the xenon gas trapped in the rocks. Xenon isotopes don't like to stay put, especially over billions of years. But in Oklo, they're still nestled where they first formed like guests who never left the party. Scientists have tried to explain it. They say maybe the rock cooled rapidly, or perhaps unusual pressure kept the gas in place. But they never sound quite convinced. Some whisper that the xenon was meant to be there, like a signature or a message. And then there's the geometry again. The zones of reaction aren't randomly placed. They appear distributed, almost planned. The spacing, the size, the containment. You pause. Your breath fogs just slightly in the humid air. Something about that word containment echoes louder than expected. That's not a word nature uses. That's a human word. You ever try to build a Lego set blindfolded during an earthquake? That's nature's typical architecture. But this is tidy, neat, tame. Which brings us back to the skeptics who still lose sleep over this. They say, if this happened once, why hasn't it happened anywhere else? Why hasn't the Earth cooked up another atomic bakery in the last 2 billion years? Why only here in Gabon? Some geologists say it's because the conditions were extremely rare. You needed the right ore concentration, the right rock porosity, the right groundwater composition, and the right geological calm. Others mutter that maybe it did happen elsewhere, and we just haven't found the rest yet. Or worse, we have. And someone made sure we forgot. You let that thought settle in. Let it climb into the hammock of your mind and gently rock back and forth. Because here's a fun little detail you may not hear in polite dinner conversation. The Oklo site didn't just burn and stop. It cycled, over and over. Some data suggests the reaction turned on and off in 3-hour intervals, like it had a built-in timer. Modern reactors have those. We program them. We design them to be smart. But here the intelligence is buried in stone. And you begin to wonder, what if intelligence didn't vanish? It just went underground. There's a cool breeze moving through the jungle now. Or maybe that's your imagination. You lie back, staring into a sky darkening with stars. Somewhere out there, entire galaxies are being born and dying. And beneath you, the memory of something that once glowed and then went silent. Maybe the Earth didn't just make a reactor. Maybe it remembered one. You're not sure when it starts to feel bigger. Not just scientifically important, but cosmically weird. Because by now the facts have stopped behaving like facts. They're acting more like riddles. And as you lie there beneath a jungle canopy older than human civilization itself, you can feel it pressing in. This isn't just geology. It's legacy. Let's talk about time. 2 billion years is such an absurd number that your brain politely refuses to picture it. Dinosaurs. They're still in the future at this point. Multicellular life is just starting to doodle with cell walls. Trees, mammals, shoes, fire, none of it exists yet. But Oklo is glowing. Oklo is splitting atoms with poise and precision. So how exactly do we square that with everything we think we know about Earth's timeline? Well, we don't. Not comfortably, anyway. Enter the isotopic stopwatch. That's the poetic nickname for what scientists discovered next. By analyzing the ratios of uranium-235 to uranium-238, and comparing it to how much of the various fission products remain in the rock, researchers were able to date the reactor's operation. The result, somewhere between 1.7 to 2.0 billion years ago, give or take a few 100 million years. And just like that, you're staring at a machine older than fossilized bacteria. Most people think of nuclear reactors as a modern invention part, Cold War part, Homer Simpson, all metal and paranoia. But this reactor hummed to life when Earth's atmosphere didn't even have enough oxygen to keep you breathing. Historians still argue whether it's scientifically useful to label Oklo as a reactor at all. Some prefer the term natural nuclear fission zone, as if renaming it makes it less mind-melting. But you don't care about academic squabbles, because you're looking at something that measured time not in days or seasons, but in half-lives. It gets stranger. The ratios of specific isotopes, like neodymium-143 and 145, or samarium-149, are so precisely aligned with controlled nuclear fission that they serve as a kind of atomic signature. These signatures tell us not just that fission happened, but how long it happened, how hot it got, and even how often it cycled. It's like finding a clock, ticking quietly in a place where no one's supposed to have ever known what time even was. And yet there's more. Some researchers point out that the uranium ore was unusually pure, far more concentrated than typical deposits of its time. In fact, it was almost too perfect for sustained fission. It's like finding a forest where every single tree just happens to be perfectly spaced for optimal sun exposure. Coincidence? Maybe. But you can't help asking the question that everyone whispers when no one else is listening. What if someone built it? Of course, mainstream science rejects this. And to be fair, there's a healthy amount of caution in not jumping to conclusions. But occasionally, a rogue paper or a late-night conference drink will open the door just a crack. What if someone mutters this was a remnant, not a machine built in our time? Not even in our age, but a leftover. A fossilized technology from a world before the world. One that wasn't destroyed, but gently paused. You shift on the jungle floor, the leaves whispering under your back. It's starting to feel less like a campsite and more like a vault. You're not lying on geology, you're lying on memory. And memory, as it turns out, is radioactive. The stopwatch of Oklo doesn't just tell you when the reaction happened. It tells you something was there, something with structure, with intention, and with patience. And even if it was natural, even if you believe in the geological coincidence version, you still have to admit this. It's the kind of coincidence that starts to feel designed, because the Earth doesn't usually play favorites. But this spot, this deep hollow in Gabon, it got the recipe exactly right. Right time, right elements, right conditions, and then silence. The uranium burned and then stopped, just like that. No crater, no fallout, just a whisper beneath the stone. And now here you are, listening. Your fingers trail along the edge of a weathered rock, not glowing, not humming, but still warm in a way your brain can't explain. And for a brief moment you wonder, what if time doesn't always move forward? What if under the right conditions it loops, or waits, or leaves behind hints? The isotopic clock ticks on. But maybe it's not counting down to something. Maybe it's counting back. You're not sure if it's the heat or the history that's making your head spin now. 1 minute you're lying in the dirt, fanning away the world's most persistent mosquito. And the next, you're mentally diagramming ancient fission cycles, like some kind of sleepy nuclear archaeologist. The Earth, after all, isn't in a rush. And apparently, neither is its memory. By this point, your toes have curled instinctively into the soil, maybe as if they're trying to plug into something older, something pulsing just beneath the surface. Let's talk about the math. I know nothing kills a bedtime story faster than math, but stick with me. This part, it's what made even the most skeptical physicists stare at their lab notes and whisper, "Wait, that can't be right." Because the way Oklo operated, it wasn't chaotic. It was elegant. See, a nuclear chain reaction requires a delicate dance of probabilities. You need neutrons to collide with uranium-235 nuclei at just the right speed. Too fast and they whiz past. Too slow and nothing splits. But get it just right, and you've got yourself a self-sustaining burst of energy. Now here's where it gets weird. In Oklo, the data suggests that the reactor turned on and off in regular cycles, like every 2.5 to 3 hours. Yes, hours. Not millennia, not eons. Hours. You're probably familiar with how modern reactors work. When things get hot, engineers insert control rods to absorb neutrons and slow the reaction. When it's cool, they pull them out and let things ramp up again. But Oklo didn't have engineers. No glowing control panels, no alarms, no caffeine-fueled night shift monitoring the core. And yet somehow it regulated itself. How most theories point to water. The groundwater seeped into the uranium-rich rock, slowed down neutrons, and allowed the reaction to start. As heat built, the water would boil off, stopping the reaction. Once it cooled, water would seep back in, and the cycle would restart. It's like a natural feedback loop, one that's so precise even today's engineers shake their heads in disbelief. Historians still argue whether such cycles could truly be sustained over thousands of years without some external interference. I mean, imagine your thermostat keeping perfect temperature for hundreds of thousands of years. Your toaster can't even do that for 3 minutes without almost setting your kitchen on fire. You laugh softly to yourself. The fan hums. A leaf rustles nearby. You're drifting, sure, but not away. You're drifting deeper, into the pulse of something no longer alive, but somehow not entirely dead. You let your fingers draw shapes in the dust, tracing the patterns of fission. But there's something else too, something the reports never quite explain. The waste. In modern reactors, spent fuel is a nightmare. It's toxic, radioactive, and stubbornly long-lived. It seeps, it leaks, it glows when it shouldn't. Yet in Oklo, much of the waste, particularly dangerous isotopes like strontium-90 and cesium-137, appeared to have migrated less than a meter in 2 billion years. That's unheard of. It's like burying a firecracker in your backyard and finding it still in the same spot after every earthquake, flood, and squirrel invasion for all of human history, plus some. Some geologists argued that the surrounding rock at Oklo was uniquely absorbent. Others point to chemical bonding processes we still don't fully understand. But there's always that nagging itch. What if the system was engineered to hold its waste? Not just run clean, but close clean. That idea that this site not only fissioned intelligently, but contained its own consequences. Well, it's enough to make any sleep-deprived scientist pour another cup of coffee and stare at the wall. Or in your case, blink slowly at the moon-filtered jungle and feel the ancient heat still faintly glowing beneath your spine. You try to picture it. Not the mine, not the jungle, but the reactor when it was alive. No humming generators, no blinking lights, just quiet fire pulsing deep in the Earth's chest. And then, silence. Because the uranium ran out, maybe. Because the water stopped, possibly. Or because whoever or whatever was watching decided the experiment had run long enough. Some even wonder if this was a power source for something we can't see anymore. A facility long lost, a city buried in time, an engine for something more than just light or heat, maybe something far stranger. You pull the blanket up a little higher, because that thought, it's cold, but also exhilarating. Because what if this isn't the only one? What if there were others you think of, other continents, Other anomalies, places where the math doesn't quite line up. Australia, India, the highlands of Scandinavia. But that's for later. For now you're here in Gabon, lying over a reactor that whispers its story in isotopes, in rhythms, in perfectly timed silences. The Earth doesn't always shout. Sometimes it just pulses, quietly, intelligently, patiently. And tonight you're finally listening. By now, the jungle has faded into a velvet hum. The air is cooler, maybe from the breeze, or maybe just your mind relaxing under the weight of too many impossible truths. You're still curled in the same spot, barely shifting, as if your body has decided, yeah, I live here now, beneath the trees, on top of an ancient mystery. And here's where your thoughts take a turn, not downward, not into the past, but outward, into space, into the question that has haunted dreamers, scientists, and mildly anxious stargazers for decades. If something once had the power to build this, where are they now? This is the moment where bedtime stories rub elbows with cosmic dread. Welcome to the Fermi paradox. You've heard the question before. Physicist Enrico Fermi asked it over lunch in 1950 while probably chewing on a piece of salami. Where is everybody? If the universe is as vast and ancient as we know it is, with so many potentially habitable planets, intelligent life should be everywhere. Cities on moons, signals in the static, visitors who forgot to wipe their prints. But there's nothing. Or at least nothing officially acknowledged. Historians still argue whether Oklo fits into this larger question. But you're lying here, 2-billion-year-old nuclear ghosts humming beneath you. And it's hard not to wonder, what if the answer to Fermi's question is already under our feet? Because what happened at Oklo didn't need to come from outer space. It could be something far more unnerving, something that started here, on Earth, before us, and ended before anyone noticed. Maybe the silence isn't because no one else ever got this far. Maybe it's because everyone who didn't make it past this point. This is what some scientists, not the mainstream ones, but the ones you find writing 10-page essays on obscure forums at 2 a.m., call the Great Filter. The idea that at some point in the development of intelligent life, there's a wall, a filter that only a few pass through, if any. It could be the leap from single-celled goo to conscious thought. Or it could be the moment you discover atomic power. Nuclear energy. The ability to rearrange matter, and with it, the fate of your entire planet. What if the Great Filter is right here humming at 0.717%, uranium-235? You shift again. The rock under your hip feels strangely warm. You tell yourself it's just the sun. Not fission. Definitely not ghosts, hopefully. Back to the paradox. One possibility is that we're the first to reach this stage, an unsettling kind of optimism. Another, that civilizations do emerge, but they don't last long after they start splitting atoms. A few years of brilliance, a flash of progress, and then silence. Oklo in this light doesn't just become a curiosity, it becomes a warning. A fossil not of biology, but of technology. Imagine a people, not humans, not exactly, but thinking beings. They live, they flourish, they discover. Maybe not phones or TikTok, but definitely physics, energy, structure. They learn to harness uranium-build reactors, calculate decay paths. And then, what did they move on? Leave Earth behind like a dusty hotel room? Or did they make a mistake? You wrap the blanket tighter around your shoulders. There's something chilling in the idea that we're not the first intelligent species to split the atom on this planet. And something lonelier still in the idea that maybe we're just repeating the cycle. Build, burn, forget, rinse, repeat. But hey, maybe it's not all doom and gloom. Maybe they didn't vanish in fire. Maybe they left because they could. The reactor stops, the stone cools, and they walk into the next chapter 1 that isn't written in rock, but in light. We always assume we're at the start of history. But what if we're in the middle, or the tail end? What if we're the reboot? You glance at the stars between the canopy branches. The same stars that shone down on Oklo 2 billion years ago, unchanged, unblinking, watching every rise and fall. You wonder if they noticed when the reactor first lit up, or when it went dark. And you wonder if they're watching now. Not in some UFO over-your-head kind of way, but in the way that the universe always watches, with patient, impersonal gravity. Your body sinks a little deeper into the ground. Not literally, of course, but it feels that way. Like you're being folded into something ancient. A memory not your own, but one you've been trusted to carry. Maybe you're not just lying above history. Maybe you're part of it now. Oklo isn't just a story. It's a question, a pause, a mirror. And you, tired traveler, are one of the few who paused long enough to listen. The ground beneath you hasn't moved. But something's shifted, hasn't it? Not physically, just in the way you're holding the story now. The way the air tastes thicker, as if the molecules themselves remember what we've forgotten. You're not alone in thinking it. That uncomfortable tingle crawling across your spine. That's not just your blanket slipping. It's the realization that maybe, just maybe, this place was never meant to be found. Because here's where the narrative begins to fracture. Not the facts themselves, but the frameworks we put around them. The neat little boxes labeled natural and man-made. Oklo doesn't sit neatly in either. It leans on the edge. The geological equivalent of a smirk. Some say it's just an accident, a fluke. A cosmic coincidence where all the variables lined up for a nuclear miracle without intention, without design. Others, those fringe researchers, the ones who whisper rather than lecture, suggest something far more daring. That what we call natural is sometimes just forgotten technology. Historians still argue whether the physical structure of Oklo shows signs of artificial manipulation. But here's what nags at them: the containment. The efficiency, the timing. In modern engineering, we measure success by output versus waste, efficiency, longevity, safety. Oklo had all three. For hundreds of thousands of years, it pulsed cleanly, safely, without catastrophic failure. A system that could run longer than any human-built reactor has ever managed. And when it finally shut down, it did so with remarkably low environmental disruption. That's not just rare. That's unprecedented. You stare up at the canopy, letting your thoughts spiral into the dark. What if we've been mislabeling ruins this whole time? Searching for lost civilizations with radar and trowels while ignoring the real evidence buried in the isotopes. Maybe they didn't build pyramids. Maybe they built things you'd never think to look for, like reactors in ancient bedrock. And maybe they didn't want to be remembered. Think about it. If a civilization reached a point where it understood the atom, where it could manipulate energy at a subatomic level, it would also understand the danger of that knowledge, the weight of it, the cost. Maybe they chose silence. They didn't leave behind monuments. They left behind stability. A reactor that shuts itself down when its purpose is done. No explosion. No lingering radiation. Just silence. The kind of silence that hums if you really stop to listen. You let your hand press against the warm earth as if waiting for a heartbeat. And for just a second, you almost think you feel one. Or maybe it's yours. Hard to tell now. There's another theory, one that gets you banned from most academic conferences. It's called the buried technology hypothesis. It goes like this: what if advanced civilizations do appear regularly, but the truly wise ones don't build upward? They build down, into the earth, into time. They don't seek visibility. They seek longevity. They embed their work in rock, in stable decay cycles, in isotopes that last longer than language. They don't write history books. They become geology. Oklo would be the perfect hiding place. Remote, stable, isolated. A place where knowledge could hum quietly, unbothered by politics or weather or war. A nuclear message in a geologic bottle drifting through epochs. And when you think about it, there's a strange poetic genius in that. Because uranium-235 has a half-life of 700 million years. If you wanted to leave a message that could last, that could still be read billions of years later, what better ink than radiation? Not flashy, not immediate, but durable. Of course, there are scientists who scoff at all this. And hey, skepticism is healthy, but sometimes it's also a little too tidy. Take the isotopic anomalies found around the Oklo site. In several samples, trace levels of plutonium-239 were found. That's not something nature just whips up on a whim. It's a synthetic isotope usually created in reactors or during nuclear weapon production. Now, sure, there are theories. Maybe it's a product of rare neutron capture events. Maybe it's contamination. Maybe. But the more you pile up those maybes, the more it starts to look like someone is trying very hard not to say we don't know. Or worse, we do know. But we're not allowed to say. You shift again, pulling your blanket tight around your shoulders. There's a chill in the air now, not from the temperature, but from the implications. Because if Oklo wasn't natural, if it was a buried machine of fossilized technology left by someone before us, then the real question isn't how it worked. It's why they left it. Was it a beacon, a power source? A test, or a warning? What if it wasn't meant to be found because it was never meant to be repeated? You lie back against the earth, letting the quiet soak into your bones. Above you, the stars shimmer like static on an ancient screen. Below you, the uranium has long since cooled. But something about this place still feels unfinished. As if the story is still happening. As if you are now part of it. You wake not with a start, but with that soft in-between twitch, the kind that says your body's been listening even while your thoughts wandered through the deeper dark. You're still there, lying on Earth's secret, swaddled in leaves and hums, but now the story is thicker, heavier, because the whispers from the deep have begun to say things they're not supposed to know. Let's go back to France, 1972. After discovering the uranium discrepancy, French scientists don't just stop at shrugging and filing a report. No, these are physicists, remember. The kind of people who eat doubt for breakfast and spit out isotope ratios for dessert. So they run tests, spectrometry, neutron flux analysis, chemical fingerprinting. And what they find, well, it starts tugging at threads the official story can't quite patch. Let's start with the xenon. You know, xenon noble gas balloon voice star of chemistry class. But xenon has isotopes, and those isotopes behave like breadcrumbs. They tell you where they've been, how they got there, and what kind of party they left behind. In Oklo, the xenon isotopes weren't scattered randomly through the rock. They were trapped in narrow pockets, trapped the way gases are trapped in fuel rods. You blink at the stars again, letting the data settle into your bones. This wasn't just leftover gas. It was gas that had been held, confined, directed. Nature doesn't organize xenon, but engineers do. Historians still argue whether this trapping could have occurred through some freak pressure anomaly or sudden mineralization. But if you ask the lab notes, those scratchy coffee-stained pages from decades ago, they tell a different story. One scientist wrote in a margin, "This pattern resembles artificial containment. It wasn't published, of course not, but it's there waiting between lines like Oklo itself. Patient, subtle, permanent." Then there's the molybdenum. Found in curious ratios, Molybdenum is another byproduct of fission, one that shouldn't show up in these quantities, in these configurations, unless the chain reaction was sustained and precise. Again, not chaotic, not accidental, controlled. And still the official reports mumble their way through it. Localized anomaly, natural heterogeneity, unusual but within margin. But the deeper you go, the more those margins start to look like walls, built to keep the rest of us out. You think back to the scientists on site digging through Gabon's sticky red clay in heat so intense it frizzled their notepads. Some of them started noticing things that never made it into final publications. Unusual isotopic banding, density shifts in materials surrounding the uranium, even traces of synthetic-like structures, tiny seams in rock that looked unnaturally linear. Now, none of this ever reached peer review. You won't find it in a textbook. But whisper networks exist for a reason. Science has politics, funding, gatekeepers. And there's something about prehistoric nuclear technology that doesn't play well in conference halls. You chuckle softly. The fan in your room hums. A motorcycle whines in the distance, a small reminder that you're still in the 21st century. Barely. Because down here, mentally crouched over ancient isotopes with your imaginary lab coat, you've started to see it. The outline, not just of a reactor, but of a system. A network of zones, a self-sustaining pattern. Evidence not of an event, but a design. And if there's design, there must be a designer. So who no names carved in stone, no blueprints buried in vaults, no radioactive graffitied monolith declaring welcome to the Atomic Age BC edition. Just this quiet intelligence, a structure that worked and then ended itself. Gracefully, completely, and if you listen closely, truly hush every thought, every bias, every urge to make it fit into the textbooks you memorized in high school, you'll hear what the scientists heard when the data wouldn't stop whispering, "This isn't supposed to exist." And yet, here it is. Now you're picturing those French labs again. The unease, the private memos, the long glances between colleagues after hours. Imagine being the person who realizes your discovery undoes history. Not a little. A lot. It's one thing to find an anomaly. It's another to realize the anomaly is older than your species. Some scientists quietly dropped out of the project. Others were reassigned. A few stayed silent for decades, only speaking in retirement interviews far from the echo of institutions. One even wrote in his unpublished memoir, "There was something about that place that felt intelligent, but not alive. Like a decision made long ago, still playing out beneath our feet. You roll to your side now, cheek pressing into warm soil. Maybe he was just being poetic. Or maybe he was right. The data at Oklo doesn't shout. It hums, in isotope patterns, in xenon cages, in molybdenum fingerprints, and in the gentle, maddening refusal to be forgotten. You close your eyes and feel the earth breathing. Not literally, but deep time has its own pulse, and now you're finally aligned with it. And somewhere beneath all the dirt and doubt, the past smiles. Not because it's proud, not because it's warning you, but because you're finally listening. Sleep is circling you now. You can feel it pacing, curious, cautious, just outside your thoughts. But the story? It's not done with you yet. Because just when you thought Oklo was a one-off, a geological fluke with too many lucky variables to repeat, the Earth throws another curveball. Other places, other anomalies, begin to whisper. Not loudly. Nothing screams in this realm of ancient energy, but faintly persistently like a memory trying to resurface through the fog. Let's talk about India. Near the city of Jodhpur, researchers once found traces of radioactive ash spread thinly across parts of the desert. Now, this isn't unusual in areas where weapons testing occurred, but no known test had taken place there, and the levels slightly elevated just enough to make Geiger counters nervous. For decades, these anomalies were dismissed. But then came the kicker: local legend. Ancient Sanskrit texts, particularly the Mahabharata, describe weapons of incredible power flashes, brighter than 1,000 suns metal, that melted the sky warriors whose bones burned to dust. You don't need to believe in flying chariots to pause at that. Because folklore isn't always just fantasy. Sometimes it's distorted memory like a dream that stubbornly refuses to leave you alone. Historians still argue whether these epics are myth or misunderstood history. But one line from the text lingers, doesn't it? It was as if the elements had been unleashed. Now, leap continents with me. Western Australia. In a remote region called Pilbara, scientists investigating ancient zircon crystals, some of the oldest minerals on Earth, found evidence of short-lived radioactive decay chains. The kind of decay you'd expect from exposure to a brief, intense burst of neutron radiation. Nothing in natural geology quite fits. Some proposed asteroid impacts. Others shrugged. But one researcher raised the possibility quietly in a footnote that the data looked eerily similar to what you'd expect from a malfunctioning fission event. And not just once, twice, different formations, same isotope trails. You stare into the dark of your room now. The ceiling has vanished into sky. You're not lying in your bed anymore, you're somewhere else. Slipping sideways through layers of earth, hopping between continents and centuries, and chemical signatures that shouldn't exist. Then there's South Africa. Beneath the Vredefort Dome, one of the world's largest known impact craters, geologists found uranium deposits that show signs of having undergone thermal alteration. That is to say, they were heated. But not by magma, not by tectonic grinding, by something internal. And again, isotopic ratios that lean just a little off. You begin to see it, don't you, a pattern? Not perfect replicas of Oklo, but echoes, faint ripples of a process that wasn't entirely local or isolated or singular. Maybe what happened in Gabon wasn't the only performance. Maybe it was just the best preserved stage. Of course, this is where the skeptics raise their eyebrows. And they should. After all, extraordinary claims require extraordinary evidence. That's the rule. But here's the problem: the evidence won't go away. It just sits there. In uranium ratios, in noble gas anomalies, in stories told by ancient people who shouldn't have known what radiation sickness looked like. But they did. Somehow. They described hair falling out, skin blistering, rain that turned to poison, and light so bright it left shadows burned into the stone. Folklore. Maybe, or legacy, not from us, not from our civilization, but from one before. One that learned what uranium could do, and then, like all bright burning things, learned what it could undo. You roll to your back again, arms folded over your chest like you're preparing for interstellar archaeology. The jungle has melted away. Now you're lying on maps, on isotope charts, on spectral lines that refuse to behave, and you think, if we found Oklo by accident, what else is still hidden? There's an old theory in archaeology called the preservation bias. It means we tend to find the things that can survive. Stone tools, bone fragments, walls. We don't find paper, we don't find code. We don't find fuel rods because most of them rot burn or are buried beneath miles of shifting crust. But uranium talks forever. It decays in whispers that stretch across epochs. It leaves clues in ratios, in ash, in the silence after something extraordinary stops humming. So maybe the reason Oklo is the only one we've officially found is because it's the only one that lasted. Or maybe it's the only one we were allowed to find. You exhale. The fan in your room ticks faintly. Somewhere nearby, the world continues its midnight routine. The fridge kicks on a car engine, growls, a cat meows like it's being auditioned by a banshee. But in your mind, the earth is still glowing. Dimly, deeply, with memories of events too old for paper but too deliberate to be dismissed. And just maybe, Oklo isn't the first. It's the last breadcrumb, or the first page, of someone else's story, one we were never supposed to finish. There's a certain type of silence that only comes after the unthinkable becomes thinkable. You know the one. Not empty, not quiet, just still. That's where you are now. Lying in it, wrapped in it like a second blanket. Because after all the ratios and isotopes and quietly suspicious French scientists, there's only one direction left to wander myth. You close your eyes and let the stories come. Not the peer-reviewed ones, the whispered ones, the ones too old to be proven and too specific to be coincidence. Let's begin with a whisper from Egypt. The Edfu Temple texts less famous than the pyramids, more obscure than the Rosetta Stone, speak of a time before time. They tell of the primeval ones who arrived before the Nile knew its name, bringing with them knowledge of the stars, energy, and catastrophic power. According to the legend, they built islands of flame across the earth, stations of energy that glowed, vanished, and left nothing behind but blackened stone. You're not saying it was a reactor, but you're not saying that either. Historians still argue whether ancient civilizations like the Egyptians, the Sumerians, or even the people of Mohenjo-Daro understood advanced science. But the ruins speak a language that is at times strangely familiar. At Mohenjo-Daro, for instance, an ancient city in present-day Pakistan excavations in the 1920s revealed skeletons lying face down in the street, as if they'd fallen suddenly, with no signs of violence. Some researchers reported unusually high radiation levels in the area. The stones had been fused together, not melted like by fire, but by something hotter, quicker. Like a flash. And just like that, you're not just lying on a quiet mystery in Gabon anymore. You're floating through layers. Because across cultures, across continents, across the ruins we casually label ancient, there's a pattern. Stories of fire from the sky, of cities erased in light, of gods who wielded thunder and vanished when the stars changed. In South America, the legends speak of Viracocha, he who came from the foam of the sea, who brought light knowledge and punishment from the heavens. And then left. In Mesopotamia, we find the Anunnaki beings described as descending from the sky with tools that could reshape the land and sky and whose wars shook the foundations of the earth. Even the Bible, if you're paying attention, tosses in a few radioactive breadcrumbs. Remember Sodom and Gomorrah. Fire from the heavens, a city turned to ash, a woman who turns into a pillar of salt for glancing backward sounds suspiciously like nuclear fallout and radiation poisoning to some people. Coincidence, maybe. Or maybe every culture remembers something, but only in fragments. Because if a civilization did unlock the atom long before us, before recorded history, before agriculture, before socks, what would remain? Certainly not buildings, not blueprints, but stories. Yes. The kind of stories that children pass around fires, the kind that elders turn into gods when the science fades but the awe remains, the kind that persist for 10,000 years because they rhyme with something real. You shift again, letting your fingers brush across imaginary carvings. You can almost feel the engravings' curved lines, spiral shapes, depictions of thunder and flame. You can almost hear the chants. And here's where it gets personal. Because once you see the pattern, you can't unsee it. You start to wonder about Atlantis, about the sudden disappearance of advanced maritime knowledge, about the Dogon tribes in Mali knowing the location of Sirius B before telescopes. about maps drawn in the 1500s that somehow depict Antarctica without ice. It's not about conspiracy, it's about continuity. You've been trained to think of history as a line, from stone tools to smartphones, from cave paintings to code. But what if it's not a line? What if it's a spiral? And what if we're not at the peak, but on one of the repeat loops? You don't need aliens or divine intervention to explain it. You just need time, because given enough time, Earth resets itself. Ice ages, supervolcanoes, solar flares, and of course, us. If a civilization got too far too fast and made the same mistake we're inching toward now, what would be left? Not much. But a reactor, one deep enough, balanced enough, and humble enough to shut itself down, that might remain. And so you return in your mind to Oklo. The reactor, the relic, the whisper. And you start to realize something. Maybe it's not just a leftover. Maybe it's a message, not in words, but in function, in proof. A quiet voice in the rock saying, "We were here. We figured it out. And we didn't destroy everything." Yet, you don't move. You barely breathe. Because now the air around you feels like it's watching. Not menacingly, just aware. Like something old is leaning over your shoulder to see if you finally put the pieces together. And maybe you have. Because if Oklo is a message, and those myths from Egypt and Mohenjo-Daro and the Andes are echoes, then you've stumbled onto something much bigger than a prehistoric curiosity. You've stumbled into a legacy, one that doesn't live in books or ruins, but in energy signatures, in patterns, in what's left behind when everything else has been erased. And here's the thing, you're not the only one to feel it. In quiet corners of academia, a few brave researchers have been mapping the overlaps, cross-referencing isotope anomalies with oral histories, high radiation sites with unexplained architectural fragments. And what they've found are threads, thin, fragile. But there, in Africa, they talk of beings who taught humans how to speak to the earth. Not metaphorically, literally how to understand the frequencies of the stones. In Tibet, scrolls describe machines that ran on breathless fire, buried beneath sacred mountains, machines that glowed softly and never aged. In the South Pacific, islanders tell of gods who lived underground beneath the hot stones, who only rose when the sky wept fire. Are these metaphors? Maybe. But metaphors don't leave behind Xenon 136, sealed in geologic glass. Metaphors don't simulate reactor cycling patterns every 3 hours over 500,000 years. Metaphors don't melt stone without a visible flame. Historians still argue whether these global myths point to a shared ancestral story or are just the result of human brains wired to fear the same elemental forces. But you're lying here listening to the Earth's heartbeat and you can't help but suspect maybe they're all telling the same story from different sides of the crater. And that brings us to the most haunting part. Because Oklo didn't just happen. It ended. Cleanly. Not with an explosion, not with a radiation leak. With silence. The kind of silence that speaks of decision, of restraint, of knowing when to stop. And you wonder what kind of intelligence walks away from a reactor. What kind of people choose to leave no legacy but isotopes and half-remembered tales? We assume the height of civilization is marked by skyscrapers, satellites, streaming platforms. But what if the true pinnacle is disappearing well? Leaving behind no war, no waste, just a hum that fades when its purpose is done. It's a strange thought, one that doesn't sit comfortably next to your phone or your Wi-Fi router. But maybe that's the point. Because deep beneath your feet, beneath continents and cataclysms and crust, you now realize there may lie more than memory. There may lie ethics, a moral code etched not in scripture, but in stone. You wonder if we'll ever be that wise. You wonder if we already were. Because here's another odd detail. Something the textbooks only whisper. The Oklo reactor zones. They didn't cross-contaminate. Despite operating right next to each other, 17 independent sites, they didn't breach leak or spiral. They stayed in their lanes. They pulsed. They stopped. It's like they were coordinated, each one maintaining balance, knowing when to yield, when to fade. Like an orchestra of fission playing in silence in the dark for no one. And everyone. You picture it now, the first modern scientists standing in that Gabonese jungle data sheets, flapping sweat dripping, realizing they'd just unearthed a reactor more stable than any we've ever built. And not one of them said this was designed. But some of them thought it. And at least one of them, according to a dusty letter tucked in a university archive, wrote, "If this is natural, then nature is the best engineer I've ever met. If it's not, then we are late to the party." You smile. Because that's the truth, isn't it? We are late, not just to the reactor, to the idea, the philosophy behind it. A civilization that learned how to split the atom, and didn't use it to conquer or threaten or brag, just to exist, quietly, safely, until it didn't, until it faded, leaving behind no ruins, no plaques, no flags, just a whisper in uranium's soft decay. That's who walked before us. Not gods, not monsters, just people maybe with deeper patience, with longer vision, with quieter hands. And maybe they're still with us not in flesh, but in consequence. In the lessons we haven't learned. In the silence we still refuse to hear. You shift again, drawing your knees close. The jungle in your mind has gone still. But the hum, it's still there. And now, so are you. There's a strange comfort in the idea that you're not the first to ask these questions. That long before you, someone else stood under these same stars or their ancient ancestors and squinted at the ground, wondering what it had swallowed. Because by now you've traveled through isotopes and folklore myths and mineral data, French laboratories and sun-baked deserts. You've tiptoed along the edge of history, leaned into whispers from stone, and heard the soft hum of a legacy that refuses to vanish. But why don't more people talk about it? If Oklo is this astonishing, this eerie, this impossible, why isn't it in every textbook, every museum, every second-grade science project? Why hasn't it been turned into a documentary trilogy narrated by Morgan Freeman and scored by Hans Zimmer? Here's the inconvenient truth. Because it doesn't fit. It doesn't fit the standard model of Earth's history. It doesn't fit the tidy arc of civilization. And most of all, it doesn't fit into funding structures. Historians still argue whether the lack of institutional interest in Oklo is due to scientific conservatism or something more deliberate. But in the end, it almost doesn't matter. Because silence has momentum. It's easier to ignore something extraordinary than to rebuild the mental architecture required to accept it. So what happens? You get sanitized reports, lab notes that redact the weird stuff, papers that focus on the natural wonder angle, no conference presentations that ask, but what if this was intentional, because asking that turns your career into toast faster than a uranium pellet in a microwave. Some researchers did try, quietly, in niche journals, in blogs nobody read, in panel discussions held in badly lit university rooms after hours. They asked the big question, what if we're not looking at an accident, but a warning? And when they did, the invitations stopped. The grants dried up. Their colleagues politely changed the subject. You lie still, eyes closed, listening to your own breathing. It's the same rhythm as the cycle in Oklo, isn't it? Inhale. Reaction starts. Exhale. Water boils. Pause. Cycle resets. There's a reason most people don't hear about this place, because it feels like it changes things, not just in science but in who you think you are. You were raised to believe we're the pinnacle, that history's arrow has only ever pointed one way up. Firewheel steam silicon AI. Boom, boom, boom. Always forward. But what if it's a spiral? What if we're not the first with nuclear fire? What if we're not even the second? Suddenly the past isn't behind you, it's beneath you. And that's unsettling. You press your hand into the mattress, half expecting to feel the shape of an ancient control panel, or the hum of spent uranium quietly aging beneath your bones. But there's only warmth, and dust, and 1,000 unanswered questions. Still, people have tried to speak. A French technician years after Oklo's discovery said in an anonymous interview, "We knew there was something more, but you can't say it. There's no box on the form for possibly not from this epoch." Others left academia entirely. One became a potter, another took up silent retreats in the Pyrenees. One wrote fiction under a pseudonym, using science fiction to say what science journals wouldn't touch. You wonder, will you forget this too? Will it fade into the same storage room in your mind where you keep middle school locker combinations and the lyrics to that one annoying jingle? Maybe, but maybe not. Because some stories don't ask to be remembered. They demand it. And Oklo doesn't nag. It waits, in silence, in ratios, in isotopes that keep ticking long after headlines fade. It's a memory with a half-life, a truth that lingers. You stare at the ceiling of your room, imagining it as translucent stone with uranium veins glowing faintly beneath. You picture them, whoever they were. Ancient engineers, or just people like us, 2 billion years smarter and far more afraid of their own cleverness. Did they walk away from it? Did they bury it? Did they know we'd come along, eventually dig it back up and blink stupidly at the data? Did they leave it on purpose? As a puzzle? A mirror? A challenge or a quiet prayer that we wouldn't make the same mistake? Because one thing is certain. They built something we still don't fully understand. And then they were gone. Not vanished in smoke or war, just absent. Like a conversation that ends too soon. Or a dream you wake up from and immediately start forgetting. But the warmth lingers. The hum persists. And the deeper you listen, the clearer it becomes. You haven't just stumbled onto a mystery. You've entered into a dialogue. And now, it's your turn to respond. You don't speak. You don't even think in words anymore. You just feel the rhythm now slow, deep, steady, like a reactor's cycle. Like a breath drawn over millennia. Because what else can you do when the earth has whispered all it can? And here's the strange part. The closer you get to the core of this story, the less it feels like discovery, and more like recognition. Like your bones already knew. Like your atoms have been here before. Now we return to that hollow in Gabon, not the pit the miners carved, but the one you can't see. The hollow in time, in narrative, in everything we thought we knew about what came before us. Because Oklo didn't just challenge our understanding of geology. It scratched the bedrock of our identity, and the wound still hasn't healed. Let's talk about that place, not the science, the feeling. Visitors, scientists, journalists, even cautious tourists report an odd quiet when they stand near the old reactor zones. Not just no birds quiet, but the kind of silence that feels like listening, not absence. The land doesn't feel abandoned. It feels retired, at peace, but watching. You can walk across it, feel the rock under your boots, hear the wind scrape against old machinery and sediment. And even if you're the most grounded, skeptical, calculator-carrying scientist on Earth, you still feel it. That soft press at the base of your skull, the idea that something's there, not physical, but present. Maybe it's just the weight of deep time. Or maybe it's because the place remembers more than we do. Historians still argue whether we should consider places like Oklo as archaeological at all. It doesn't have artifacts, no bones, no pottery, no ceremonial altars. But maybe that's the point. Maybe the artifact is the Earth itself. After all, what greater monument could a civilization build than something so integrated into the planet's body that it survives for billions of years unnoticed, not to impress, not to control, just to exist precisely and peacefully? Think about how we build things, huge, noisy, complicated, prone to breaking, designed to be maintained by armies of technicians, computer systems, and spreadsheets. But Oklowit ran without maintenance, without input, without humans, and it knew when to stop. It left behind no wreckage, no warnings, just a humming absence. And for some, that's what makes it unbearable. Because the moment you admit Oklo might not be natural, you have to admit something more advanced than us once lived here. And not only lived, but lived better. You hear the protest in your mind. But we have space travel, we have AI, we have microwave popcorn. Yes. But they had stability, patience, systems that didn't just work, they stopped working when it was time. That's harder to build than any spacecraft, harder than fusion. It's humility made into hardware. You lie back again, your body a tuning fork for ancient frequencies, and then a thought drifts in quiet and soft. Maybe they didn't disappear. Maybe they just let go. They reached the mountaintop. They saw what came next. And instead of racing there, they folded their hands, closed the book, and chose peace. Can you imagine that? A civilization that didn't build endlessly until it collapsed, but one that saw the end before it arrived and stood still. Not in fear, but in wisdom. We have a word for that, but we rarely use it for technology enlightenment. You're not asleep yet. But you're close. The fan whirs. The lights have blurred into fuzzy glows. Somewhere in the back of your mind, the story is still playing, but it's quieter now, more gentle. Because maybe the Earth has told you all it can, and the rest, that's for you to carry, not with urgency, not with panic, but with stillness. You breathe in, you breathe out, and the hollow beneath you breathes too, quiet, timeless, not an empty place, but a place of completion, of knowledge folded into the soil, of voices not erased, just done speaking. And now, the hum begins to fade. Not abruptly, not like a switch, but gently, as if even the echo of the story knows when it's time to leave you in peace. You lie there cocooned in the warmth of ancient secrets, your thoughts softening like embers cooling after a long, slow burn. And still deep beneath you, though no longer audible, Oklo remains, still humming, still holding, still remembering. Because some memories are not made of words or stone. They're made of balance. You picture it again, those 17 quiet cores tucked beneath the earth, pulsing in cycles of 3 hours for hundreds of millennia, like a heartbeat, like the breath of something ancient and careful. They were never loud. They never demanded your awe. But now that you've heard them, you can't forget. Maybe that's the whole point. Not revelation, not alarm, just recognition. You are not the first to walk here. You are not the first to build. And if you're lucky, if we're all lucky, you won't be the last to understand how quietly, beautifully, and deliberately someone can walk away from the edge of disaster and leave only peace behind. And now that you've listened to the silence, now that you've floated through the ratios and the reactor cycles and the long-lost caution of a forgotten age, you feel it. A gentle hush in your chest. A sense that you're carrying something now. Not heavy, just real. Like a memory you didn't live but still somehow belong to. Maybe that's what Oklo was meant for. Not to change the world, not to rewrite the textbooks, just to whisper. So that when the time comes when we finally look inward with quiet eyes and ask, are we doing this right? We'll have something ancient, patient, and wordless to remind us what careful power really looks like. And now, dear listener, dear traveler of ratios and ruins, let it rest. Let the hollow in Gabon be still. Let your mind float. Let the questions blur softly at the edges. There will be time in waking hours to remember them again, to wonder, to dig deeper. But not now. Now let it end the way the reactor did, gracefully, deliberately, peacefully. Let your body melt into the bed, your thoughts trailing off like the last gentle ring of a faraway bell. You've walked through ancient jungles, traced your fingers across the memory of uranium veins, and listened to a story told not in words, but in half-lives and quiet design. Let the stillness hold you now. You've wandered a long way, but you've done it slowly, softly, like the earth itself remembering something sacred in its sleep. Let that silence wrap around you. You don't need to carry the whole story forward tonight. Let the questions rest unanswered. Let the facts float like leaves on still water. They'll be there when you wake. For now it's enough to have heard the hum. To know there's a place beneath the soil that glowed and cooled quietly without applause, and to feel in your own breath a rhythm that echoes it. Inhale, pause, exhale, stillness. Again, slower this time. And now if sleep finds you, and it will let it be gentle. Let it come like mist curling over ancient stones, like the hush of a reactor that chose silence over fire. Let your last thought be not of mystery but of grace, the kind that builds without pride, the kind that ends without fear, the kind that knows how to let go, and simply rest.